Let's continue our journey with logical operators. Logical operators are again heavily used for conditional checks. We will cover them in detail later once we have covered conditional checks. Treat this as just an introduction to logical operators. The double ampersand and is different from single ampersand and. Remember, the single ampersand binary operator is used to perform bitwise AND operation. The conditional or double ampersand operator is used to evaluate the expression consisting of two expressions or value. The expression or value P double ampersand Q evaluates as true if both P and Q are true or false otherwise. Next, we have the conditional or the double bar operator, which is used to perform the conditional OR operation. The expression P double bar Q evaluates as true if any of the P and Q expression or values are true and false otherwise. Last, we have the exclamation mark or the NOT operator. It inverts the value of the operand. Please note it is a unary operator too. So if the expression P or value is true, not P expression will evaluate as false. If P is false, not P expression will be evaluated to true. Let us look at some other operators we haven't covered till now. All operators that you see here are unary operator. First up, we have the double plus sign or the increment operator. It is used as postfix notation and increments the value of numeric type operand by 1. So P plus plus would increment the value of P by 1. Similar to the increment operator, we have the double minus sign or the decrement operator. It too is used as postfix notation and decrements the value of numeric type P by 1. So P minus minus will decrement the value of P by 1. Next, we have the ampersand operator. We have already seen two variants of the ampersand operator. The single ampersand binary operator is used for bitwise operation, and the double ampersand operator is used for conditional checks. The one we have here is a single ampersand operator, which is an unary operator. It is used to fetch the rest of entity in memory. Ampersand P will give you the rest of entity P in the memory. The next one, or the asterisk, is the dereferencing operator, which, given the rest in memory of an entity, the asterisk operator is used to get the value of the entity stored at that address. So asterisk P, where P stores the address of the entity, or in other words is a pointer, would return the value stored in memory at the address stored in P. We will talk about both the res and dereferencing operator when we talk about pointers in depth. The last operator we see here, represented by a combination of left arrow and a dash, is called the receiving operator. It is used to receive values from channels. Now, what are channels is something that we will cover in more advanced sections of the course. Channels are used for communication between two coroutines, which are used for concurrent programming. For now, it's okay to just know what the operators stand for. Let us now talk about operator precedence. Have you heard of the term PEMDAS? It is an acronym used to learn order of precedence in math or order of evaluation for a mathematical equation. If you have an equation which has multiple mathematical operations, you would follow PEMDAS rule to evaluate it. P stands for parenthesis, which is always the first to be evaluated. E stands for exponent, which are evaluated after parenthesis. M stands for multiplication, which is the third precedence of operation and is evaluated after parenthesis and exponents. D stands for division, then A for addition, and S for subtraction. Operator precedence is very similar. In programming, the PEMDAS rule will still apply, but there are other operator precedents that should be considered. Unlike other operators, the increment and decrement form a statement and not an expression. As such, they are not really considered in the operator precedent. For simplicity, we just think of them as having the highest precedence. This is to say they are the first one to be evaluated in an expression. Next in the precedence ladder, we have a group of binary operators that have the next highest precedence. If found in a single statement, they will be evaluated from left to right. The next group of operators has sum, subtraction, bitwise OR, and bitwise OR. Again, in the same statement, they will be evaluated from left to right. In our precedence ladder, they have level 4 of precedent or are the third highest precedence. In level 3 precedence, we have comparison operators. When found in the same statement, they will be evaluated from left to right. In level 2 of precedence, we have the logical AND operator, followed by the lowest precedence operator, which is the logical OR. So if an expression has all these operators, they will be evaluated from top towards bottom in the order of precedence. 6 is the highest precedence and 1 is the lowest. If you are confused by operator precedence when writing code, I would suggest you to write the expression in an innermost parenthesis which you want to be evaluated first, followed by the next level in the outer parenthesis, and so on. I will show you how I like to write my code when I am confused about the precedence of operation. With practice, you will get a hang of the order of precedence, but it is a good thing to keep in mind when writing code. That doesn't mean you need to remember everything by heart. The majority of programming is just trial and error. In my opinion, that is the best way to learn. I hope you enjoyed the lesson. In the next lesson, we will cover arithmetic operators followed by bitwise operators in depth. Please feel free to comment under the video if you have any questions, or you can also reach out to our Discord server. Thanks again for watching. See you in the next lesson.